Okay, here we go. So we're grading the white today. The test is on Tuesday. Because I spent so much time yesterday working with several of you, trying to help you get better and better prepared for the test, I didn't have time to make up quite as fancy of a grading key as I had when we did the purple. So be a little patient as we go through how it's graded. It won't be quite as polished, but I still have the same information. The first few are done. I just didn't have time to do all of them. So first one is finding an area. This one's worth 4 points. They give you 1 point if you have the correct limits. First limits are 3 to 4. Second integrals limits are 4 to 6. They give you 2 more points if you're defining the integrands properly. To define the integrands properly, you've got to make sure you tell them what f and g are.
They already told you what f of x is, so do you need to restate it?
Oh, thank you. No need to restate f.
Okay.
Because
you need to restate the other one?
the other one, I would not want to use this. Y is way too generic. It doesn't.
I use the L thing.
L. They might give it, but it's still not very standard. If you did that today, go ahead and count it, but adjust your habit to use something more standard. It's just safer. Questions? Please.
Also, if I get the area different, is that okay? I mean, I got the right answer.
Tell me what you wrote.
So I did integral.
Hold on, I gotta write it down.
Integral from 3 to 6, and then I did the L, but I did g of x, d of x. Is g of x the L one? Yeah. G of
Hold on a
x, d of x.
second. Let me pause.
Okay.
So what that will do is that will find an area here.
Yeah.
Keep going.
And then I did subtract the integral from 3 to 4 f of x, d of x. Could you just
Yeah, that's okay.
That's okay.
Yeah, good work.
Is there a better way to, like, is there, like, is one way better than the other or no?
I wouldn't say better. I would say the way I did it is a little more, like I can use this. It's a very good method. It really is.
Yeah.
I don't want to
No,
criticize
you're
it
totally
at all. No, sometimes I will. Sometimes I'll say, nah, it's not quite as good as this. The method I use is a little more, I would say, universal, meaning I can just always apply it. It always works. I don't have to think in a different way. I just think always the same way. So it's kind of like one method fits all. Emma's a bit more creative in how she did it. So that's good. Cool.
If I didn't answer it just saying equals 7.917, I said the area of S is 7.917, is that okay?
That's okay. 3 points for Colin for asking. Anybody else? Wave if you need more time here, otherwise we'll move on.
I can explicitly state that f of x and g of x, I just use L. Would that give me 2 points?
If you used L today, don't take away any points. Just don't use it in the future. It's not a real common notation.
So same type of thing, like I wrote L is equal to g of x, but then I never explicitly said that f of x was that because it said it was probably.
Yeah, that part's totally fine. So this is a mistake on my part. There really was no reason for me to stay F.
So would it really only be worth 1 point for that part?
No, I just accidentally put that in there. So really, that's all you need like that. So, please.
In an AP problem, would it be fine, would you still get the 2 points if you just referred to g of x as L because it stated that it was L in the prompt?
Say it one more time, Anna.
Would it be okay to do everything the same except call g of x L because it says that in the prompt? Would you still get the points?
It's borderline. The reason I say that is, even though they said L is the line, that's not usually a very appropriate way to name a function. So, give yourself the point today, but in the future, try to stick with like F, G, H. It's more standard. So 3 points for Parker and Hannah for asking good questions. Wait if you need me to wait while you take notes. Otherwise, I'm going to change the slide. No one is waving. Okay, cool. Number 2. At what time is the volume of the tank greatest? This is a min-max problem. 4 points is what they gave for this one. Very similar to what we graded on the purple.
If I put gallons in the tank, is that okay?
Good enough, yep. Please.
If I named the 14 like h of t, and for the g prime of t, I did h of t minus r of t, does that work if I stated what I was talking about? Okay.
Yeah, as long as you're using the equal sign appropriately, you're totally fine.
How did you put the 14 gallons per hour in your calculator? Like, do you need to do 14x plus 2,500? Like, do you need to put that in your calculator to be able to find, like, to use G prime?
What I did is what I always do. I put my in rate in Y1. So let's see if I have this 2008 S number 1. Let me get the actual calculator, Ellie. 2008 S number 1.
Like, I didn't know what to put in for Y1, I guess.
Gotcha.
Or I guess Y2 is what you put in.
I did it backwards on this one. I shouldn't have done that, but oh well. So this is my out rate.
Yeah.
This is my in rate.
So it's just 14.
That's actually, and then my overall rate, of course, is in rate minus out rate. Everybody look. This is a place where I've seen people lose 12 points instantly. They make one mistake and it leads to the entire problem being wrong. That in rate right here is simply 14.
Why wouldn't it be 14x?
Let's talk about that to make sure it sinks in and makes good sense. Let me get a table here. Hold on a second, Ellie.
For every hour, doesn't it go up 14 constantly? So when you need an x to
Represent that.
yeah.
Let me type it here. 1 second. Okay, so here's what Ellie's talking about. And I'll warn everybody in the room once again. If what I'm about to show you does not make sense, you're losing 12 points on Tuesday. Like, this is not a, how would you say, hollow warning? This is a real warning. Gotta get this one right. Let's go to blue is good. Okay, so what we're talking about is we have a situation where we're talking about a 24-hour period, so we definitely have time involved. Put a T right there. And then we have the in rate. They didn't give a name for the in rate. Somebody called it H. That was Ellie in the back, right? So Ellie in the back called it H of T, which is totally fine. That's optional. You don't have to. But we'll do that just as an illustration. So we have that. So here we go. Come on, you dumb boy. So I underline this. That's better. Okay, everyone in the room, raise your hand. According to the story, oh wait a minute, we got to do something else here. And then a suggestion was that this should be 14 times t. That's what Ellie in the front said. Should be the rate. So let's test and see if this works. So according to that table, raise your hand please. What would be the in rate at time 0? If the your hands up. If the in rate is 14 times t, what is the in rate at time 0? Let's go, Sadie.
0.
Sadie says 0. Who agrees? 2 points, 3 for Sadie. We go to hour 1. Hands up. What would be the rate of incoming water? Hands up. What would be the rate of incoming water? Let's go Marin in the front.
At time 1, 14.
Marin says 14. Who agrees? 2 points. 3 for Marin. Go to time 2. Hands up. What's the incoming rate? Let's go Chris. 28. Chris says 28. Cool. We have a question so far. Cool. So, now, here's the problem. That is not what the story says. Who can explain that? Please.
It's just constant saying that it's 14 per hour, so we're just going to get 14 every hour, not exponential.
Correct. Yeah, the rate is not supposed to be increasing with time. The rate is simply supposed to always be 14,
Okay.
independent of time. That's why this 14 does not have a T. It's just always 14.
So 14x would be the equation for the particle. Like, kind of. Like if you go back, you do the antiderivative of that. 14x.
That's actually correct. The antiderivative of the 14 is 14t. And you can think of 14t as a way to calculate how much water flows into the tank.
That's kind of what I was.
Yeah, this is what this is. This isn't the rate of water flowing in. This is how much water has flowed in.
Yeah.
It's also not what the level of the tank is, because that's more things are involved, like how much is flowing out, what the level was. Yeah. Please.
Test scores are really strict on whether or not you round. Because I forgot the nearest gallons, so that means.
They're very strict. They'll take away the point. Yeah, try to give you a pretty straight judgment on like when is it kind of borderline, when is it like, yeah, pretty safe that they won't take away a point. When they will there. Okay, cool. Let me fix my little table here for the future, just to make it look a little better. So this is what we really want. So if our in rate is equal to 14t, we get that. But what we want is this. We want an in rate that is just equal to 14. So that we would get this situation. Questions from anyone? Wave if you need me to stay on this slide. Okay, next one. Get that out of the way. What is the acceleration? That's a 1 pointer. 1 point. Questions? Oh, please.
That's the units of measure. That's the same as miles per minute squared, right?
Absolutely.
Okay.
3 points for Grace. We need to stay here. No one's
You
waving.
can kind of swap stuff around. Like I did a of 23 equals the derivative
Got it.
of f of t.
Yeah, just as good. Either way. 3 points for Ellie. Please, partner.
Just wondering, like, what's the difference between saying like d of f of t when the line's at 23 versus just saying d of f of 23?
Ticket for that one. I feel like the ticket questions are ones that nobody has a clue why, so they go, oh, ticket for that one. Yeah. Only I know why it's so important. But I will try to explain to all of you why it is so important. Here's why. Parker. This is saying we want to find the difference in two values of f that are really, really close together. Ideally, infinitesimally close. That's what that means. And really, we want three values because we want to do a secant left and a secant right, and then a secant left. So we're comparing values of f that are very, very close. That's what that's trying to accomplish, is it does the comparison first, like it does that around t equal 23. That's what it's trying to do. If you plug in a 23, it disrupts the whole thing. Because now you're asking for something different. You're saying, we'll go see how much this value is changing compared to itself.
Okay.
So let's see how many in the room can answer this correctly. If you're comparing this to itself, who knows what the result will always be. You're finding the difference in two values that are the same value. What is the result always going to be, Spencer? I just had to laugh. He's like resting on a park there, and then we're just chill here. How many knew 0? 2.3 for Spencer. Questions? Oh, please.
For this problem, do you need to put a of 23, or do you just put d of d of t, or d over d of t of f of t?
I think that it is. I think it is a 80% probability that you really should have that. It's very high. This one I would say optional.
Okay.
Optional. I like it because I feel like I'm communicating to the grader what I'm finding. So the grader's digging my grave. Gravy is everything.
I was thinking gravy.
Like the person who dispenses
Gives you the gravy.
is the graver. That's funny. Check around. Where's the graver? Questions? Oh, we need more time here. Moving on from the graver. Okay. That was terrible. It's on the video and everything. Sorry. I can't remember if I told you this. I thought it was hilarious. One time a student comes in, she goes, Mr. Smith, I was watching one of your videos. And you know how you when the class starts to talk a lot, you're like, okay, come back, you whistle to just get your attention, She's like, I was watching the video and you whistled, my dog came running. Like the dog heard the video. Okay, here we go. Average velocity of the plane, this is a 3-pointer, this is money. That's what Clark said I'm supposed to say, money. This one is money. It's not just money, it's money in the bank. Please, Ellie.
If you write miles over minute.
Oh yeah, same
is
thing.
that okay?
Same thing. 3 points for Ellie.
Do you need the average velocity equals that? Or?
No, you don't really have to have the words, as long as you have the other parts of it. Never hurts to kind of tell the grader, hey, I know what I'm finding, but sometimes the words can get a bit lengthy, and I don't even like to do that. So yeah. It's like this one, Ellie. If there's a symbol that I can use to communicate very quickly, I like doing it. So the grader knows I know exactly what I'm talking about. If it's a bunch of words, even I won't always have the patience to write them out. So.
Okay.
Gonna need more time here. No one's waving. Keep going. Now we're into the ones where I didn't have time to make a key, so we'll have to be a little creative. Find the acceleration of the particle. So this is how it would be graded. Let me show you the key. I gotta move my monitor. Hold on a second. It's on the wrong screen. So here's the answer to number 5. Well, as we're here, I'll copy and paste it over. There you go. So there's the acceleration of the particle at time equal 4. That is a 1-point question. 1 point. Yeah, please.
For that question, are we required to have the equals A4 equals
Yeah, hey, very much like the last one. This part here, look where I'm circling. That one I'd say you better have, because you got to tell the grader how you're doing it. Whether you have A or 4 or not, somewhat optional. Definitely have to have the 0.714. So as long as you have the first element perfectly written and the last, and that 3-digit number, you'll get the point. And again, that is 1 point for that problem. We copy that over. Questions? We need more time on number 5. Okay, here we go, 6. We're finding all times in which the particle changes direction. So, 1 second, let's fix this as well. This one is worth 3 points. Here's how they would have graded it.
If you did like the v of t equals 0 when t equals 1 and t equals 2, does that also work?
Let me read the problem here, Ellie, 1 second.
Because that's what I did today.
Okay.
Find all times in the interval when the particle changes direction. You do have to be a little careful. 2005B number 3. Let's get a calculator up here. 2005B number 3. Okay, so we're plotting the velocity of the particle. So here's a picture of the velocity. What you did, Ellie, is certainly valid. Like, you do have to have more than that. Because just because the velocity is 0 does not mean the particle will change direction necessarily at that time. So you do have to be a little bit careful with that. It's a good place to start, but you have to have more information than just when v of t is equal to 0.
So like if I said the particle changes directions at time at t equals 1 and t equals 2, and then for the second part I said from that 1 is greater, t is greater than 1 but less than 2, the particle is moving left. Is that like enough?
Did you tell them why the particle is moving left during that time?
No.
Like how you know that?
So I would need to put v of t is negative.
Right.
Okay.
So read your whole question again. Read your whole answer again, sorry.
I said v of t equals 0 when t equals 1 and t equals 2. So then I concluded that the particle changes directions at t equals 1 and t equals 2. And then for the second part, like when does the particle travel to the left? I said from when t is greater than 1 but less than 2, the particle is moving left.
Gotcha. I think they give you 2 out of 3.
Okay, but I would need
The reason is the part you're missing.
the v of t is negative.
Yeah, like I gave a reason both for how I know the particle is changing direction because I explicitly showed that when VFT changes sign, the particle changes direction. And then I gave a reason why I know it's moving left. Cassidy, please.
Where in the answer did they set VFT equals to 0? Like, did they or did
Good
they?
question. They did not, I did not specifically do that step per se, but these are taking the place of it. If VFT is changing from positive to negative and negative to positive, I've correctly found when VFT is equal to 0.
Okay.
So I didn't do it explicitly, but I did it in a different way, so they would have given me that point. Good question, good point.
So is it better for me to write it instead of doing the VFT equals 0 when blah, blah, blah? Would it be better to do at t equals 1, VFT changes positive to negative? Like, is that?
For this one, it's
For this
better,
one, it's
yeah,
better.
because it wants to know when the particle changes direction. Please, Parker.
So if I say something like, the particle changes direction when VFT changes sign, is that?
Oh, that's pretty good. You could say the particle changes direction when VFT changes sign, which occurs at t equals 1 and t equals 2.
Yeah, and then I said that, and then I just said it travels left when VFT is less than 0, which is when 1 is less than t, which is less than t.
Yeah, what you said was particle travels left when VFT is negative,
Yeah.
which is the time interval from 1 to 2. Yeah, that's fine. 3 for 3. Does anyone want me to type up some of these alternate phrases that people have said? I'd be glad to type it on the board if it would help you. Anyone's asking. Okay, cool, making sure. You would need to stay here. Okay, moving on, number 7. That one was 3. That one was 3 points. Finding a position of a particle. Here is the scoring for that one. This one is also worth 3 points. Right here is what I would have, I don't have a good way to work this board without copying and pasting. This is what you need. Let me go to the back again, hold on. It's worth 3 points. To get the 3 points, you must properly use an integral. The integral must be of the velocity. Here we go. So that's what you need right there. Here's how the points were awarded. Okay, you get 1 point if you have the integral from 0 to 2 of the velocity, dt. That's 1 point. You get a second point if you remember to add to that integral the value of x of 0. You could type x of 0 or you could type 8. It wouldn't matter. So whether this says x of 0, this says 8, both are correct. Lincoln?
So if I just did the, my integral was integral from 0 to t of v of alpha, d of alpha, and then it was x of t, and then my answer was x of 2 equals 8.369. Is that fine?
Yeah, you should be fine with that. You got the right decimal. Please, Ellie.
Do you need to state that x of t is like the position of the particle?
Outstanding question. With x of t, v of t, and a of t, I've never seen them require that you have to state it.
Okay.
You can just assume that that's accepted. Please, Emma.
If I didn't like specifically write out equals 8.369, but instead I did it in a sentence and I was like, the position of the particle at t equals 2 is that, does that
Oh yeah, that's totally fine. 3 points for Emma, Parker, and Ellie. Do you need me to stay here at all? Okay, next one. 8. This one is worth 2 points. You must have the correct integral. You must have the correct answer. Here's where you can get some partial credit for a mistake. If you forgot to multiply by 1/2, but you still have the integral from 0 to 2 of the absolute value of velocity, you would still get one of the 2 points. Questions on number 8? Please.
Why is this one the absolute value?
So it asks for the average speed.
Yeah.
Speed is the absolute value of velocity. But it asks for the average velocity, we would have no bars.
Okay.
Does that make sense?
Yeah.
3 points for Grace. Anybody else? But need more time here. Number 9. Here's what you must have for number 9. You must have the velocity at time 4. You must also calculate and show them how you calculated it, the acceleration at time 4. And you must have the correct reason that the speed is increasing because v of 4 and a of 4 are both positive. Please, Parker.
So I said that the speed of the particle is increasing at time equals 4 because velocity of 4 is greater than 0 and the acceleration of 4 is greater than 0. Would that give me the points?
That is a perfect explanation. Did you have on your paper the value of the velocity at time equal 4?
I did not.
Okay. Did you have on your paper the value of the acceleration at time equal 4?
We did that in problem 5.
Oh, fair. Earlier, right?
Yeah.
I think they give you 1 of 2. Like, you have exactly the right reason, Parker. They just want some evidence. How did you know v of 4 was positive? So they want you to write it down so you can see that it's positive.
Okay.
Your question will be for Parker.
Because it is part of the same problem, we used in on 5, do we need to have the d of t over d of t?
Like Parker said, on a real AP test, this would have been like 1 FRQ. And if you've done it in one section, you don't need to do it again. Please.
When writing like d of v of t over d of t, what if you substituted the bottom t for x?
Oh, gotcha. Fairly disastrous in this case because x is representing position. If everything else on your page is correct, they probably would let that one slide. It's like, oh, it's just a little glitch. Just try not to. You know?
Wait. Oh, yeah.
3 points for Parker. Any other questions? 2 points total on this one. We need more time here. Okay, number 10. Three points. Questions on 10? Please, Cassie.
Why are we using the absolute value if it's not a speed?
3 points for Cassidy. Okay, so I have a new sign on the board, courtesy of Miley Robbins. It says it's the inside that matters. So when I explain what Cassie's asking about, and actually whenever I explain integrals, you should notice that I don't start with the integral. I start with the inside. Once you understand what's going on inside, everything else comes together pretty easily. So we did this the other day, so some of you are familiar with this little discussion, but let's do it again. If you have a particle that's moving, and that particle is moving at a rate of, say, -2 meters per second, and it has that rate for 5 seconds, what could you tell me about that particle? Hands up.
Is this the velocity?
So the velocity is -2 meters per second, and the particle has that velocity for a total of 5 seconds. What could you tell me about the particle? Hands up. For those 5 seconds. Let's go, Ace in the back.
The speed of the particle would be 2 meters per second.
Oh, very good. If the velocity is -2 meters per second, the speed is absolutely 2 meters per second, for sure. I'm combining that fact with the velocity will be -2, 3 points for Ace, for 5 seconds. What do you know combining those two facts? What do we know? Let's go, Colin.
The particle will be 10 meters to the left.
From where it was.
Yes.
So we could do this. We could say, hey, we multiply this by an amount of time here, a duration of time. We get -10. How many were prepared to say that? Show me. 2 points, 3 for Colin. Hands up. Displacement or distance traveled? Trick question. Hands up. Displacement or distance traveled? It's kind of a trick. Is this number displacement or is this number distance traveled? It is kind of a trick question. Hands up. Displacement or distance traveled, Lincoln? This number is strictly displacement. Particle is 10 to the left from where it was. 2 points if your hand was raised, 3 for Lincoln. Distance traveled would be a +10. So that's the displacement. Questions so far?
Just because it's negative.
I wouldn't say that's the best reason, but ish. What I mean by that is, I cannot have a distance traveled that's negative. I can't have a displacement that's negative, because displacement is like, where am I relative to where was I? 3 for Jackson. Hands up. Displacement one-handed or two-handed number? Hands up. There you go. Spencer's keep his hands like that. Everybody look at Spencer and please raise your hand. Is displacement a one-handed or two-handed number? That's what I do. Like, I don't know how to say, I don't know how to describe it. You know, it's like I was here, now I'm here. So I've displaced -10 from where I was. How many knew? 2 points, 5 for Spencer. Okay. Please.
And then with distance, you said, like, I remember saying, you said yesterday that like the one-handed is distance traveled or something.
No, I can't do that either. Position is one-handed.
Oh,
Like, I can say, oh, does that make sense?
Yeah, I'm getting it now.
Yeah, Grace is like, I go home and dinner, like, what you learn in calculus? We learned that displacement is 2 hands, but I don't know what the crap he's talking about. Something to do with 2 hands. You know. Is that better?
Yeah, I get it.
3 for Grace. Look, position is one-handed because I have this line along which I move, and we kind of just put a mark right here. We say, oh, I'm at this spot. I said to Liza yesterday, distance travel is like a string. When you walk, you have a string in your hand and you're letting it out. You keep letting it out. You keep letting it out. Then you stop and you say, well, how far did I travel? Well, however long the string is. That's distance traveled. So, hey, stay here. Look. Let's say for the next, I don't know, 3 seconds, the particle now has a velocity of 4 meters per second. For 3 seconds, what would you know? Hands up. Particle now has a velocity of 4 meters per second for a total of 3 seconds. What would you know, Brooklyn?
You travel 12 meters?
Definitely traveled 12 meters, 3 points. Do we know anything more than just the fact that we traveled 12 meters? Like, a key thing you're not saying is we went to the right. Kind of key. How many knew? 2 points, 3 for Brooklyn. She's like, I don't know if that's that important, Mr. Smith. Look. Hey. 3 meters to the right.
Isn't that like 3 seconds?
That would be seconds. Thank you. 3 points.
Why is the mouse glitching?
Oh, why is it all
It's stressful.
jittery?
Yeah. I had like a heart attack.
It does look a little tense. The board's a little tense today. The software has a glitch, in my opinion. They should not have done that, but maybe they wanted to on purpose. I don't know. When I'm recording, it does that. Like it can't quite keep up, you know? It's a little glitchy. So let's make sure the microphone is still running. Yeah, we're good. We're still talking. It shut off last time. We good? Cool. That was just a setting in my, like I told you I designed that, right? Like I was one of the design team. Yeah. One of the settings.
It's cash.
It's cash?
Cash.
Oh, it's cash. One of the settings is like you can push go and it will automatically stop when it finishes the measurement. I forgot to turn that off, so yeah. Moving on. Hey, raise your hand, please. If this was a particle that we were studying for an 8-second time period, what would be the total distance traveled of this particle for the 8 seconds? Hands up. What would be the total distance traveled for this particle for the 8 seconds? Louder. Emma. Emma says 22. Who votes with Emma? 2 points, 3 for Emma. The total distance traveled would have been 22. 10 to the left, 12 to the right. Okay? If I want total distance traveled, I cannot have any negatives. That's why when you're finding total distance traveled, look what we're doing. Look, it's the inside that counts. You're taking a velocity times the duration of time. Velocity times the duration of time. Velocity. Oh, but wait a minute. It can't be just velocity. It's got to be absolute value of velocity times duration of time because we can't have any negatives.
So the two times that we need to use the absolute values, the total distance and speed.
So speed is equal to the absolute value of the velocity.
That's because you can't really have a negative speed.
Can't have a negative speed. That's just how it's defined.
Yeah.
If I'm finding the average speed, therefore, I'm going to integrate the absolute value of the velocity over some time period to find the average speed. Something like that. If I'm finding the average velocity, I want to make sure I count negatives. So I'm finding the average velocity, I'm going to do this, 1 over 10, 0 to 10 of just the velocity. If I want the total distance traveled, here we go, total distance traveled. If I want the displacement, I do not want absolute value because I want to keep track of negatives. I don't know if I answered your question, Cassie.
Yeah, you did.
Okay. 3 points for asking. Oh, please.
So there was a question last time where it was talking about like a plane and it was saying the velocity is always positive. If you got an average speed question on that, would you technically have to put the absolute value there or no?
Not technically.
Okay.
Because if they declare that the velocity is always positive, that means the velocity and speed are exactly the same.
Okay.
Good question. 3 for Grace. Hey, I think I said this one to Liza. I can't remember. We got quite a few little memory tricks the other day. I thought it was helpful, hopefully. Look, I pointed out to Liza, my apologies. Thanks. I pointed out to Liza that the way to keep track of it is no sign with speed. Like speed is always positive, so you have to have absolute value. Go back to Jackson. Total distance traveled is always going to be positive. So you have to integrate the absolute value of the velocity to find total distance traveled. That has helped Aaron as well. If you are looking for the displacement, you have to keep track of negatives. Therefore, you have to be integrating the velocity. So, questions? So it is very related to like, do I need to keep track of negatives or not? Okay, next one. 11. Wow, there's a lot of stuff. Particle is furthest right of the origin. You do not have to have this part here. This was just me clarifying. As I just said to Ellie Wagaman, they'll accept that X is position and V is velocity. They don't have to state those. This part here is just me restating the question. It's a max-min question. A lot of things here just to clarify. They're not essential. This part here is essential right here. V of t is equal to 0 at t equal 1 and t equal 2.
Do you need the x of t as a max value, like to state that the endpoints could be a possible?
Not required.
Because you put that in your candidates test? And that
Correct.
Okay.
So that's just me, as I talk at the board, I try to be as clear as possible. The black right here is required. You have to have the black. That's how we begin every min-max problem. Please, Parker.
So instead of x of t, you can use anything else technically?
As long as you tell them.
One of the first problems we did a of t, and so I've just been in the bad habit of like doing a of t.
It's not so bad. Oh yeah, don't do that because that means acceleration.
Yeah, but if I say that it's position, is that okay?
As long as you use a capital for the position and a small for the acceleration, it's okay. I can't see how they could take away points as long as you tell them. B for Parker, please.
You don't have like written out anything? Do you need to have anything?
I don't know what you mean by written out.
Like saying the particles.
Oh, thank you. No, I just hadn't gotten that far.
Okay.
Thank you. 3 points. So here's the first point right there. Let me show you how it was scored. This one is worth 4 points. So it was 1 point. It was 1 point for that. Then it was 2 points for all of this work right here. We could have done this with a single formula and a candidate's chart as well. So that part right there is worth 2 points. And then like Emma said, you do need to have a final answer that says, hey, the particle is farthest right of the origin at this time, and the position at that time is going to be the 12.740. Please.
Can you remind me how your points are different from the AP points?
Oh, thank you. All I did, Ellie, to make sure it would fit in Skyward, is I said, okay, we got to have a test that's worth 100. I'm going to give you 10 questions on Tuesday.
10, that's it?
Right. Sprinkled amongst the 10 are 25 points. 25 AP points.
There's like A, B, and C.
Okay. No, they're not. No, it's just 10 questions.
It's not like 10, 8, like.
So do people
It's
finish this test
like on the practice test here, right?
So like this.
Like this is one question on the test that's worth 4 points. But I call that one question on my test. On my test, one question worth 4 points. This would be one question worth 3 points. This would be one question worth 2 points.
So it's smaller than a packet.
Smaller than the packet. Smaller than the packet. This one was 14, yeah?
Yeah.
This one's 14 questions worth 34 points. Your test on Tuesday is 10 questions worth 25 AP points. All I do is multiply that by 3. So we'll add up your points, multiply by 3, give you 25 for taking it on time. That gets to 100.
Could you go back to that last question on the question?
Which one?
Like
Number?
11, I think. Yeah.
Yeah.
So when it says x of 2 equals b plus whatever, and then x of 1 equals c plus 2, I just don't understand how those two are different.
These two here?
Yep.
Oh, they aren't, because it's a mistake on my part. I'll give you a ticket for that.
Wait, what's a mistake?
There's a typo. Who sees the typo? Look hard. Passing out tickets here in a second. Who can see the typographical error between these two? Clark saw it. It was good work. What is it, Grace?
It should be a 1 at the top of the interval.
Which integral?
The bottom.
Yeah, this should have been 0 to 1. I obviously put a 1 when I did it because I got a different decimal. Otherwise, it would have been the same as the other one. That looks like 11 now, brother. What do you guys say nowadays? It is a thick one. What do you say nowadays when you do something like that and you're like, oh shoot? What do you say? Don't say oh shoot.
Oh, no, what I said.
No slang for that. Oh shoot, shoot's good.
Yeah,
Still valid, 50 years later. Cool. What do you say?
Joy.
Oh joy.
Yeah, it's not.
Oh joy. Yeah. Oh joy.
Nice way of saying it. No, like someone cuts me off in traffic. I'm like, joy.
That's funny. I gotta pay for that. That's a good one.
I didn't even know I would get a ticket for that.
And that's what it's there.
I've been fortunate not to have been in an accident, other than I was rear-ended once. But I had a close call the other day, and I've been traumatized ever since. Like I can't pull through an intersection without getting nervous. Like I was turning left at the intersection by Costa Vida, and some guy about slammed into me. Like he ran the red light bad. Like it'd been red for like 5 seconds.
Actually, no, I started.
And he's like looking at his phone, just driving through a red light.
That was me when I got hit in the parking lot. Now every day after school, I'm
Yeah.
running to my car so I get out.
Don't you get nervous?
Yeah.
Yeah. It's weird, huh? Like you can't, like I'm getting over it, but every time I'm like, I don't dare go through this intersection. Okay. Question. 4 points. We good?
Yeah.
Cool. Break a leg and die.
Alright, this is an interesting conversation. She's hit deer before. Okay, no. It's recording.
They could do these, I promise. It's okay, moving on. Moving on. Okay, here we go. Here's how this one was scored. 12. Ellie, did I answer your question? 12 is a 2-pointer. That's what you must have for 12 right there. You do not have to have the 25.1. You just have to show how you are finding the trapezoidal sum. Yeah, I wouldn't want to check it either.
If I got the right answer.
If you got the right decimal, you're in good shape.
Wait, what part do you not need to have?
So here's the deal. Hey, look out. Warning. The average must have a 1 over 15. So if you forget the 1 over 15 here, you just got 1 out of 2. Got to make sure you get that. You do not have to have the 25.1. You are allowed to stop once you have written out all the terms of the trapezoidal sum.
Do you need to have 25.100 if you were asking for like the actual
The 3 decimal kind of
Yeah, you
thing.
need the 3 decimal.
I always put them because that's the rule.
Do you technically couldn't you just put the answer, or do you need to literally write?
Oh, good question. Let's see what they said. Hold on a second. This one didn't say to show. This is a pretty old test, 2001. More recently, it's been pretty common that they'll say show. So I always show. The other reason I show is because it's safer. Like if I make a mistake, in like typing it in my calculator, I'm gonna lose the point. If I just write it all out correctly, I get the point.
So would you suggest not putting the answer at all?
My vote is not to put the answer.
It's so hard not to. It's like there's just no satisfaction. It's like this. We need an actual.
I agree.
No, I typed that.
The
It's
satisfaction
like
comes when you grade
minutes.
the satisfaction when you grade the test and you get the point. So
That's true.
Yeah.
please, Lincoln.
Even though we don't need 25 don't you need degrees Celsius? Like,
Oh, I don't know.
is that necessary?
It did not require the units, so not required. Always a good idea, but not required.
And for the answer, do you need the brackets around the, like on the inside of the interval? Do you need the brackets?
Oh, thank you. Hey, you got to indicate that it's 1 over 15 times all of it.
You just do some really.
So big parentheses are just as good as brackets.
That's what I did.
3 point.
I also didn't know this would work. I just didn't want to try it because I think. But could you also do? So you have 115 on the outside of the big bracket. Could you also do 1/2 and 3? Because in this problem, 1/2 is being multiplied to all of them and 3.
Yeah, you can factor those out if you want. Is that what you mean?
Yeah, that's what I was.
Yeah, so you could say I've got out front a 3 over 30, which is 1 over 10.
Okay.
That's legal.
Yeah, that's what I was.
You can do that. Yeah. We need more time here. 13. There we go, 1 pointer. It's a foul shot, free throw, 1 pointer.
This is a kind of tricky one too. So like, last time we you multiply by how much you're adding up.
Say one more time, Mark.
Like you know how you multiply? It's like you add up and then you divide to get the average.
If it's an average, this one didn't ask for an average.
Oh, sorry.
So,
That makes sense. No worries. 3 points for us.
so if I wrote that, but then I did like this. How do I explain this? So if I wrote that, then I also wrote the like same of the left side and then had it approximately.
Let me just
Yeah. Would I, if like I did all the math wrong, but I still have the equation written out right, would I get a point?
Oh, you're saying like if you got the answer
Answer
wrong.
wrong.
Oh, God. Hey, take it for Emma. Joy.
I'm doing good. Yes. Joy.
Look up.
That's a good joy though.
The reason I said joy, here's why I said joy. Listen. Zach has returned to his original residence. There we go. Look, if you work an AP problem, every warning, big warning. It's why I say don't keep going. If you have all of this and it is correct, the grader takes out his pen and he's about to write 1 over 1. But then he sees that you wrote this, like you put on the end over here, like you just couldn't help yourself.
I was targeting.
Did you see I was targeting?
Yeah, I was targeting.
That's true. I'll give you a
No.
Okay. Ellie is correct. I was referring to Ellie. It was very targeted.
No, this is good.
If you cannot help yourself, and so you write an answer, and the answer is incorrect, that the grader goes, oh joy, and then he has to put 0.
I really want to.
Does that make sense?
Yeah, no, it does.
Please, Parker.
And once again, since it doesn't say you have to put units, you don't have to put gallons.
You are correct. Please, Clark.
When will we have to?
Oh, take it for that.
Is there a good question?
That's a good question. When they say things like, round your answer to the nearest whatever, then I gotta have a number. Like all those calculations aren't rounded to anything. So
I put gallons on this one.
if you didn't,
Yeah.
they didn't require units, so you're okay. It's always good to put them just so you don't forget to put them, but they didn't require it. So 3 for great. Here we go. That was targeted. That was very gentle.
That wasn't, I don't know, it wasn't meant to like, I was not offended.
offense or
Okay,
anything.
making sure.
Yeah, don't worry.
I worry a lot about that.
Oh, no, I was doing.
I'm like the board, I run on high anxiety. This is how I am. My wife's like, she's always telling me, you just gotta help me learn to not be so tense. I'm like, I am like the Golden Gate Bridge. Tension is what holds me together.
That is a good saying.
Like a world with intention, but fall apart.
Writing it down.
Oh boy. That's not very healthy though. I'm trying to get last in. Oh, another one that's oh, please.
Last question, I plugged in all of the answers twice and I got 3,700 as opposed to 3,600.
3,700 was the correct answer. No, you're good.
You were saying like what?
Yeah, I was showing what would be a problem is if you, yeah, we were laughing a lot, so people in the back didn't know what we're talking about. The video's terrible. And, okay. All right. Here's the answer to 14. No, it's not a good thing when you go see the cardiologist and he says to me, he says, well, you have a big heart. Not a good way. Yeah, okay. But I did surgery and now I'm better. Okay, cool. Just a few years ago. All good. Questions? Please.
Let's leave that negative over 3.
Yeah.
Let's check here. Hold on. Okay, here's a warning, everybody. 3 for Aaron. Aaron gets the ticket for asking. Good job, Aaron. Here we go. This one says, you must show computations, you must indicate units. So even though it is it's a one-pointer, isn't it?
Yeah.
Even though it's a one-pointer, it's fraught with peril. Okay? Does everybody know what fraught means? Fraught, like it's like perils everywhere, you know.
It's like English.
I think that's we're like every subject.
Whoa! Like analogous. You did that the other day too.
Yeah.
Okay, look. You must show where the numbers come from. You must show where the numbers come from. If you do not show where the numbers come from, you don't get the point.
So you have to put W9 minus W.
So you either have to have this right there, or you have to have this right here.
Wait,
one of the two.
Didn't you just say if we don't show where it comes from, we'll lose points? So we have to have W of 9.
What I said was you got to show where it comes from. They are accepting of either.
Oh.
So if you show this one, come on board. That one, you're okay. If you show this one, you're okay.
You just show the answer.
If you just show the answer, no point.
Can you just stop? Like if you have W prime of 7 equals 28 minus 4 over 6 minus 9. And
Stop.
you have Celsius over
Stop.
days.
Okay.
Yeah.
I stopped there.
Good stop. That would be my preference for the answer. I would go like this. Read it to me. I would go.
Equals 28 minus 24 over 6 minus 8. 9. Celsius over 6.
Like that?
Yeah. Celsius.
Is that correct?
Yes.
That would be my preference. That would get you 1 out of 1. So.
So it's okay to have, so on the other one that shows the answers, it has, yeah, go ahead. So on the first one it's 9 minus 6, but on the other one it's just 3. Could you put 9 minus 6?
It would be better to show 9 minus 6. 3 more.
Because it says find the approximation, wouldn't the answer be, or wouldn't we write it as W prime of 7 is approximately, and then
3
write
points.
the problem?
Well done. That would be the best for sure. I do think they'll forgive that one if you forget, but it is definitely the best. 3 points for Lincoln. Please.
I just put degrees Celsius, not degrees Celsius per day, so is that wrong?
So you would get 0 out of 1. Fraught with peril. Please.
Sorry, I wasn't sure if we like. You have to have it
You have to have what you see here. If you have more and it is correct, you're still safe. If you have more and it is incorrect, you now get 0 out of 1. Does that answer it? Read from Merit?
Is there a way to know like how much questions were when you just take the test?
I'd take it for that.
What is this out of?
34.
Oh, yeah.
I think I counted it right.
Yeah, I just.
No, it wasn't. Like I say that with sincerity. Like I'm like,
34.
it wasn't meant to be cynical at all. It was more like,
Yeah,
I because I mess up all the time.
No, I think it is 34.
It is, okay. Look, listen to Sadie's question. Okay, when you take the actual AP test, they do not tell you how the points are distributed. Other than, I've shown you before that when you take the test, you're given a notebook. And when you open the notebook, like this, the FRQ is both pages. That is always 9 points. You just don't know where the 9 points are distributed. Now, we practice a lot, so you get kind of a sense of it. Like I can usually guess, oh, that's a 3, that's a 2, that's a 1. And sometimes I'm off, but not usually. Question. Okay, just like before, it's out of 34. I will have posted, I have not done so yet, but there'll be a Canvas item. You go in, you do the Google form, you tell me your score. Test is on Tuesday.
When you upload this video, so you just...
Correct. Any other questions here before I stop the video? Thank you for the reminder. So this will also be posted.